Number one, we have I to the fifth. Okay, I to the fifth. We need to remember how I works. All right, well, the first part is obvious. I equals I. We also need to remember the fact that I squared equals -1. Okay, and then I to the third is really an I squared times another I, which would mean that this is -1 times an I, and -1 times I is -I. And then I to the fourth, that one's a beautiful one, because if we know that this fact that I squared equals -1, which we should all have memorized, then I to the fourth is really an I squared times I squared, which is really a -1 times a -1, which is a +1. So knowing these four, all else could be done really easily. What do I mean by this? I do have I to the fifth, which is simply I to the fourth, which is really 1 times 1 more I. So let me actually write that out for you. I to the fifth is I to the fourth, which is really 1, times 1 more I. So what is 1, the number 1, times I? Well, that's just I. So the answer is just I. I hope this makes sense. Again, using these four, you'll be able to answer any other ones. So let me actually jump to number 2, I to the 43. And we are using, again, these four facts that, well, I is I squared is -1, I to the third is -I, and I to the fourth is 1. Since we know, this is a very, very important one, since we know that I to the fourth is 1, then any I to a certain power that's divisible by 4 will end up being 1, right? If you're able to group all these 43 I's, imagine that. You got I times I times I times I, and see, this right here would be a group of 4. That's I to the fourth. So that's really a 1, right? And then you have times I times I times I times I. That's another group of 4. So that's another times 1, right? So if you're able to group all of these I's into groups of 4, then they end up being 1 times 1, which they pretty much eliminate, right? So the question is 43 divisible by 4? And the answer is no, it's not. If you were to go 43 divided by 4, it would go in 10 times, right? But you would have a remainder of 3. Or you could think of it this way. 4 times what will get you close to 43 without going over? 4 times 10 would get you close to 43 without going over. But how many more I's do you need to get to 43? Because 4 times 10 is 40. Well, you need 3 more. So you could think of it as a division problem with a remainder, or you could think of it as multiplication and see how many more I's you actually need to get to 43. So I guess we could conclude that I to the 40th is really 1 times I to the third. And again, if you know these 4, I to the third is really -I. So right here, the answer is I to the 43 is -I. That is the answer for I to the 43. I hope this explanation helps. If not, ask me in class. All right, this is just a review question here, solving, right? And I hope we remember from the last test that you're going to divide by -3, divide by -3. We do end up with x squared equaling a -8. And yes, we are going to square root. And remember, when you apply a square root in an equation, you're going to have a plus or minus in front of your answer. But not only that, you actually have to simplify the square root of -8. So what is the square root of -8? That's really I. The negative sign comes out and it becomes an I. Right? So you have an I times the square root of 8. Now the square root of 8 is not a perfect square number, but you could rewrite it as 4 times 2. That way you could get a perfect square number, which is 4. And of course, you still have the I that's in front. So what we have here is I times 2 times the square root of 2, which ends up being 2I square root of 2, right? Putting it in order. You always want to put the number first, then your variables, and then your radical at the very end. So 2I square root of 2, it is a plus or minus. So that would be a plus or minus 2i squared root of 2. This is your answer. X equals plus or minus 2i squared root of 2. And if we look for that answer, that would be right here. X equals plus or minus 2i squared root of 2. Let's move on to the next question. I'm sorry, in this one I cut off the multiple choice. So that was an accident. So let me just explain it. When I distribute negative 3i times 2, that's like negative 3x times 2, that'd be a negative 6x, but in this case, negative 6i. And then we distribute negative 3i times negative 5i. That would be positive 15, and with an I squared. Now, keep in mind that I squared is really a negative 1, so you might as well right below replace the I squared with the negative 1, and then bring down everything else, the 15, the minus 6i. And so right here we have a positive 15 times a negative 1. That's going to end up being a negative 15 with a 6i in front. But we should remember that complex numbers, when you have a real part and an imaginary part, the real part goes first. So what is the real part? The negative 15. So I'm going to rewrite it as negative 15 and then the positive 6i second. Positive 6i second. And this is the correct form of your answer. Negative 15 plus 6i. We're going to have some ridiculously easy ones right here. This is really just a binomial and a binomial, and you're subtracting them. So the safest way to do this would be to distribute that minus sign to both of those and rewrite everything. We have a 3 minus 2, 3 minus 2i, that is. So 3 minus 2i. I just rewrote it because there's nothing to distribute here, so there's no need for these parentheses. So I just rewrote it. 3 minus 2i, there it is. And over here, I'll get a minus 5, and then I'll also get a plus 5i, okay? And now the question is, let's just combine like terms. Let's begin with the real part. 3 minus 5 is negative 2, and then the imaginary part, negative 2i plus 5i, that's a positive 3i. And that is your answer in the correct form, negative 2 plus 3i. On this one, we're going to distribute. So we have 3 times 3, that is 9. 3 times 2i, that is positive 6i. And then negative 2i times 3, that's a negative 6i. And negative 2i times positive 2i is a negative 4i squared. Now keep in mind that I squared is really a negative 1, so you might as well replace the I squared with negative 1 that you are going to multiply with this minus 4. But anyway, what else is happening here? We could combine the middle terms, the positive 6i with the negative 6i. That eliminates. We end up with 9. And over here we have a minus 4 times a minus 1. That's a plus 4. So your final answer here is 13. 9 plus 4 is 13. And this one is a type in your answer. That is simply a 13. This next question is ridiculously easy. All they ask for is a complex conjugate. What is a conjugate? It's the same binomial, but all you do is change the middle sign. So that's going to be a minus. There's your complex conjugate. You got it. That's like a free point right there. We're supposed to remember that you don't want to leave a square root in the denominator or an I in the denominator. Now, if you had a binomial in the denominator, you'd have to multiply by the conjugate, both on bottom and top, the same binomial with a different sign in the middle. However, in this case, we are just going to multiply by I because we don't have a binomial. We don't have a 7 minus 3i. If I did have a 7 minus 3i, I'd have to multiply both top and bottom by 7 plus 3i. But I don't have a 7 minus 3i. I just have 3i. And I could get rid of an I simply by multiplying by one more I. So I could multiply by one more I. And what I do to the bottom, I must do to the top. So we are going to multiply by an I both on top and bottom. We're going to distribute I times 8 is 8i. I times negative 6i is negative 6 with an I squared. So that I squared is negative 1. Let's replace that. Put a negative 1 right there. Bring down the minus 6. You might as well multiply. Negative 6 times negative 1 is positive 6. And we do have an 8i right in front. The 8i comes down. Not only that, we do know that that's out of order. You want the real part first and the imaginary part second. So we really end up with a 6 first and plus 8i second. Now, what do we have in the denominator? That was just a numerator. This is what's on top. So let me put that fraction bar. And on the bottom, we have I times I, which is I squared. And of course, we have a 3 in front. So 3 times I squared is really 3 times negative 1, which is negative 3. So that's the denominator, negative 3. But we need to split this because you can't have a real and an imaginary together. We're going to take this denominator of negative 3, split it to each of the terms, and we will have 6 divided by negative 3 plus 8 divided by negative 3 with an I next to the second fraction, and of course reduce any fraction possible. In this case, you could actually divide 6 divided by negative 3, that's negative 2, and then plus 8 over negative 3 with an I, and that is your answer. Negative 2 plus 8 divided by negative 3 with an I, or that negative might be written as a minus sign in the front, and yeah, that's what they do right here. That's your answer. Again, the difference is that the negative, we don't normally leave it at the bottom, so I'm just going to move this negative out here to the front. So that would, final answer would be negative 2 minus 8 over 3 with an I. There's your complex answer. There it is. On this question, we do have a binomial in the denominator. We will have to multiply by the complex conjugate, which is the same binomial, but with a minus sign in the middle. So we're going to do the same for the top. Okay. And we're going to distribute on the top. 3i times 3 is 9i. 3i times negative 2i is negative 6i squared, but we should all know that I squared is really a negative 1. So what I really have is a negative 6 times negative 1 with a 9i right in front of it, right? So what do I have really? I have a 9i in front, and I have a plus 6. But that's out of order. You want your real number first and your imaginary number second. So let's put the 6 over there, the 9i over there. So we have a 6 plus 9i, because it was positive after all, so plus 9i. So that's the correct order. This is our numerator. All this work was just for the top. So question is, what do we have on the bottom? Let's figure that out. We have 3 times 3, that's 9. 3 times negative 2i, that's negative 6i. Positive 2i times 3 is positive 6i. Positive 2i times negative 2i is negative 4i squared. So we're going to combine the middle terms, and we will end up with nothing, because when you combine those, they cancel out. But what do we have left? We have the 9 right here. We have a 9. We also have a minus sign, but we have a 4. But we might as well put the times I squared, which is a negative 1. So you have to multiply before subtracting. Negative times a negative is a positive. So we have 9 plus 4, right? A negative 4 times a negative 1 is a positive 4. So you have 9 plus 4, which is 13. So we have a 13 down here. You want them separate. Let's get them separate. Let's put that 13 on each of the 6 and the 9i and reduce if possible, but we cannot. We have a 6 over 13 plus 9 over 13 with an I on the second one. That's your answer. Now, I don't know why, but it should have been separate. They kept it together. I guess we're going to keep it together on this one. This is the only correct answer. Yeah, so normally we would separate, but right here they kept it together. All right, let's move on. I to the 23rd. On this one, again, we want to use the fact that if you're able to group the i's, again, imagine there's 23 i's. There's I times I times I times I. That is barely 4 of them, but we know that I to the 4th, we know I to the 4th is really 1, right? So, and then you have another times I times I times I times I. That's another group of 4, and we know that I to the 4th is really 1. So if you have a bunch of i's that are grouped in 4, that ends up pretty much canceling out. So if the 23 i's could all be grouped in groups of 4 with nothing left over, then your answer would be 1. But how many i's would you have left over? Well, we know 20 would be is divisible by 4, so 20 would be able to be grouped in 4 i's each. So if I were to rewrite this as I to the 20th, how many more i's would I need to get back to the I to the 23rd? I would need 3 more i's. So again, because this is grouped, or I to the 20th could be grouped in 4s, we know that this is really just 1, all right? This right here is really just 1, okay, times I to the 3rd. And what's your final answer going to be? In case you forgot that I to the 3rd is really negative I, in case you forgot that I to the 3rd is really negative I, you could actually work this out right here. I to the third is really I squared times one more I, right? And what is I squared? That's -1. And what is -1 times I? -1 times I is -I. So if you forget that I to the third is -1, you could always work it out to get your answer, -I. So your answer here on number 10, or on this question, is -I. Let's move on to the next question. We are simplifying square roots. So right here we would separate the square root, would separate it to the 9, separate it to the x to the 16th, and the square root of 9 is really 3, and the square root of x to the 16th, remember that a square root is really the power of 1/2. So what we have is x to the 16th inside the parentheses to the power of 1/2, and we should know that a power to a power, you multiply 16 times half, that will be x to the 8th. So your answer is 3x to the 8th. Now, not all of them will work out that great, but this one does. This one right here, you have the square root of x to the 25th. We do not want an odd power. We want an even power because a square root is really the power of 1/2. So if you do have x to the 25th in here, 25 times 1/2, that doesn't work out that great. So what's a better thing to do? Instead of jumping right into that, we're going to actually rewrite the 25 as 24 x to the 24 times another x, okay? That way we could split the root, and that way we could now actually divide 24 by 2 because the square root is the power of 1/2. So 24 divided by 2, that will give us x to the 12th. And what about the square root of x? That just comes down square root of x. So there's your answer, x to the 12th, square root of x, which is right here. Let's move on. I apologize on this one. The answer choices got cut off, but it's the same. Well, I'll explain it here. We're going to split the root to each and every one of these terms. The square root of 49, the square root of x to the 9th, the square root of y to the 16th, and the square root of z. Okay, which of these are really easy to do? Well, this one's easy to do. That's just 7, right? 7. So 7 is going to be in front of your answer. What else is easy to do? Well, the square root of y to the 16th, that's an even power. That's really easy to do as well. Let me explain. So you really have the power of 1/2 instead of the square root, and you do have y to the 16th right in there. So a power to a power, you multiply, so 16 times 2 is 8. So what we really have is y to the 8th. Okay, now the z, the square root of z, you can't even do that, so you're going to have to bring that down. And the square root of x to the 9th, that one you're going to actually have to do some work. You're going to rewrite it as x to the 8th times x to the 1. You're going to split the root. That way you could actually do the square root of x to the 8th. That's really just taking the 8, dividing it by 2, and that'll be x to the 4th. And the square root of x to the 1, that's going to stay the square root of x. So what we have here really is the first part of our answer is 7. Let me write that down, 7. Then we're going to move on to x to the 4th, x to the 4th, and also y to the 8th, y to the 8th. And finally, our square roots put together, the square root of x and the square root of z is going to be written as the square root of x and z together. So there's your final answer. I apologize, I cut off the multiple choice, but this should be your multiple choice answer. If you don't see it, then you would select none of these. On this next question, we are selecting all the true statements. A square root is the same as the power of 1/2. Of course it is, so that's true. Select that one. This guy, the square root of x to the 16th is not x to the 4th. Do not pick this guy, right? You're not doing the square root of 16. 16 is not a number. 16 is an exponent, right? It's a number that's an exponent. So do not pick that one. That's incorrect. Okay, this one is correct if you actually show your work. You have the square root of x to the 9th, but you don't want x to the 9th. You want an even power, so you could rewrite that as x to the 8th times 1 more x, and you could split the root. And of course, right here you end up with x to the 4th with the square root of x, and that's what it says right here, x to the 4th square root of x. So this is definitely correct. Please pick that one. What else? This is also true. if you were to split the square root to the 9 and split the square root to the x squared, the square root of 9 is 3, and the square root of x squared, the square root and the square undo themselves. So you really end up with a 3 and an x. There's your answer, 3x. So these are our 3 correct options. So on this question, we have the square root of 25x to the 4th, y to the 16th, z. And we should know how to simplify this. The first thing to do is to split the root to each and every one of these. So we're going to put the square root of 25, the square root of x to the 4th, the square root of y to the 16th, the square root of z. Okay? So which of these are easy to do? Anybody? Yeah, 25. What's the answer there? 5. Okay. This one's also easy because a square root is really the power of 1/2. So if you think about that, there's an x to the 4th to the power of 1/2, and we know that a power to a power you multiply. So 4 times half is 2. So we'd end up with x to the 2nd. That's really easy to do. And this next one, y to the 16th, that's also easy to do. What's that? Yep, y to the 8th. All right, so keep in mind, guys, that this 16 is not a regular number 16. It's an exponent of 16, right? So we must remember that the square root is really the power of 1/2, and inside there we have the y to the 16th. A power to a power you multiply. What's half of 16? It's 8. So that's how we get the y to the 8th. Okay? Last but not least, z. The square root of z, you can't do it. So you just bring it down. Square root of z. And believe it or not, that's your answer. Right there. 5x squared, y to the 8th, square root of z. If you would have had other square roots, like if you would have had the square root of x, you would put those square roots together and it would be the square root of xz. But in this case, it worked out beautifully. The square root of 25 is 5. The square root of x to the 4th is x to the 2nd. The square root of y to the 16th is 8. So once again, don't make the mistake of thinking that you did the square root of 4. You didn't. You did not do the square root of 4 right here. That's really 4 divided by 2, which gave you 2. You did 16 divided by 2, which gave you 8. Okay? You don't square root exponents. Technically, they become a division problem of 2. That's why we want even exponents. And this one on the test will be multiple choice, and there it is, the correct answer. What do you guys think the answer is to this one? 2x, right? You really have 4 times x, so you split the root. You could do the square root of 4. That's the nice answer, 2. You can't do the square root of x, so you just leave it. So 2 square root of x. Not 2x, but 2 square root of x. Get it? Okay, so all these questions you will be seeing on the test. And this one, multiple choice, it's right there, but sometimes you won't find it and it would be none of these. But of course, right here it is. Continuing with simplification, I know you guys could already see the answer, sorry about that. So let's split the root. So we really have the square root of 20 and the square root of x to the 3rd, and that's really like doing 2 simple problems. The Casio calculator could actually do the square root of 20 for you, but let's not rely on calculators. We want to rewrite it with multiplication to get a perfect square number. 2 and 10 would not cut it. 4 and 5 would be the better option because, or actually the only option, because 4 is a perfect square number. So you split the square root. The square root of 4 is 2. The square root of 5 stays. Now let's look at this next one, the square root of x to the 3rd. We want this to be an even number. Because we know the square root is the power of 1/2, we want this to be divisible by 2, but it's odd. So what I want to do is rewrite it with multiplication as x squared times another x. That way I could split the root and I could actually do this square root of an even power because it's like dividing by 2. So what is the square root of x squared? The square root and the square eliminate themselves, right? So you end up with just x. And what about the square root of x? That just comes down, you can't do it. So what you really have here is 2 square root of 5, which is really 2 times the square root of 5, times x times the square root of x. Since it's all multiplication, you could just rearrange it. Final answer will be 2x square root of, put this square root and that square root together, number first, letter second. And if you had several letters, you would put them in alphabetical order, right? Anyways, there's your answer, 2x square root of 5x. This one's ridiculously easy. What's the conjugate of that? Anybody? That's right. What is the conjugate? Simply the same exact binomial, but you only change the middle sign. Don't say opposite. It's not the opposite, right? You didn't change this sign. You only changed the middle sign. Or you could have also said only change the sign of the second term. That used to be a positive square root of 7. It's now a negative square root of 7. On this one, we're subtracting. So, oh yeah, by the way, this one it clipped off the multiple choice, so I apologize for that. But let's subtract, and in case you don't remember how to subtract, you take that minus sign, you distribute it to both terms, and you rewrite it. You really have a minus 4, and you have a plus 3 square root of 2. Now, notice that there's nothing to distribute out here in front of this parenthesis, so you're just going to bring that down. You really have a 6 square root of 3 plus 3 square root of 2, and then minus 4 plus 3 square root of 2. So out of all of these 4 terms, are there any like terms that I could combine? I can't combine these guys because you have 6 of a certain thing plus 3 of something else. But I could combine this 3 square root of 2 with that 3 square root of 2. Right? So those 3 square roots of 2's could be combined. I have 3 of these specific square roots of 2's. I have 3 more of those same square roots of 2's. So I will have a total of 6 of those square roots of 2's. What else? I want to put my minus 4 out in front. I want to put this positive 6 square root of 3 right there. And there's my answer. Minus 4 plus 6 square root of 3 plus 6 square root of 2. I guess it doesn't really matter which order these guys are in, right? But let's put that nice number out in the front. So I don't have the multiple choice answers here to compare and see which one it is. Just keep in mind that it doesn't really matter the order right here. It might be negative 4 plus 6 square root of 2 plus 6 square root of 3, or it might be written exactly like this. Or it might not be there at all, and you would say none of these. On this one, we're going to distribute. 2 times 3 is 6. 2 times square root of 2 is 2 square root of 2. Square root of 3 times 3 is positive 3 square root of 3. And then square root of 3 times square root of 2 is positive square root of 6. And if we look at these 4 terms, you cannot combine these 2 middle ones because they're not like terms. You have 2 of these guys and 3 of these guys. You cannot combine those. Can't even combine it with that one. Actually, you can't combine anything, so there is your answer. Now, I know that on a lot of these square root problems, the Casio calculator could do it for you, unless it gets too long. I believe on this one, if you type this in the Casio calculator, it'll give you the answer as an irrational decimal, a crazy decimal. I don't think it'll be able to give you this whole answer. So keep that in mind. You weren't able to combine any of those terms, so there is your answer right there. Moving on to imaginary numbers, let's distribute. Negative square root of 5 times square root of 3. We have both square roots and imaginaries in there. That would be negative square root of what? 15. Okay, and then negative square root of 5 times negative I. What's a negative times a negative? Positive. And we have a variable times a square root. Just put them together, the variable and then the square root. Okay. And now let's distribute positive 2i times the square root of 3. That's going to be positive 2i square root of 3. And positive 2i times negative 2i, a positive times a negative is a negative. We do have 2, and we have I squared. But we need to remember that I squared is really a negative 1. So you really have a negative 2 times negative 1, which is a positive 2 at the very end. And I technically cannot combine anything else. So I do have negative square root of 15 plus I square root of 5 plus 2I square root of 3 plus 2 at the very end. This is my answer. Well, technically, here it is, down there. It's that answer choice. Exponents. Talked about exponents already. What's the answer there? X to the what? 5. There you go. X to the 5. Too easy. What's the answer there?
9x to the 6th.
Is it 9x to the 6th?
Oh, no, wait.
3x to the 6th?
No,
What rule are we using here? You have parentheses with an exponent on the outside. You take that exponent and you distribute it to the terms on the inside, right? There's a 1 right here. Power to a power multiply. So you end up with 3 to the 3rd. Distribute it here. Power to a power multiply. X to the 6th. Okay. But what is 3 to the 3rd? Is it 9? No. What is it? 27. Yeah, because 3 to the 3rd is really 3 times 3 times 3. So that's a 27 x to the 6th. So that would be your correct answer for this one. It is multiple choice. And there's your correct answer, 27 x to the 6th. How about this guy? What's the answer to this guy? What do we do with negative exponents? We move them to the other side. Circle whatever has a negative exponent. Remember, the 2 does not have a negative exponent. So you're still going to have a 2 right there, but you're going to end up moving this guy down to the other side to make it positive. So down there, you're going to have an x to the positive 3. And that is your answer, 2 over x to the positive 3. 2 over x to the positive 3. Which, when you look at your multiple choice answers, it's not there. So that would be none of these in this case. Oh yeah, it's getting more fun. What could I cancel or reduce? Anybody? What cancels right there? What do I have left over if I reduce 4/6? 2/3, right? If you reduce by 2, 4 divided by 2 is 2, 6 divided by 2 is 3. How about those x's? I have 5 x's up on top, 7 on the bottom. All 5 x's cancel with 5 of those. I will have 2 of them left over. How about the z's? All 4 z's up on top cancel with 4 of these z's, and I'll have 5 left over. How about the y's? I can't cancel the y's. I have a negative exponent down here that needs to be moved up there. So what I have left is a 2 up on top, a y, and then the y that I just moved over 3 x to the 2nd, z to the 5th. Again, 3 x to the 2nd, z to the 5th. So what left could I do? What's left that I could do? The y to the 2nd times y, that's y to the 3rd. Final answer, 2 y to the 3rd over 3x squared z to the 5th. So that's your answer. And when we look for the answer down here, it's going to be this one. On this last question, we need to remember that anything to the 0 power is 1. So what we have here is 5 times 1, because x to the 0 is 1. So if you have 5 times 1, that is the answer 5. Not 0, not 1. The answer is 5. So on this question, we have to apply many, many rules of exponents to be able to simplify this. We're going to begin with the rule that when you have parentheses with an exponent on the outside, we're going to distribute it to both terms on the inside. So that will give me a 3 squared and an x squared. When you put that 2 on the 3, put that 2 on the x, you get 3 squared and x squared, which is technically 3 squared is 9, and x squared stays x squared. Okay, but we still need to multiply it by whatever is going on over here. Okay, so what is going on over here? Inside parentheses, we have the negative exponent 5. And remember the rule of negative exponents, you have to grab it, move it to the other side. So even if it's not a fraction, you can make it look like a fraction and move that x to the negative 5 down to the bottom, and it'll become x to the positive 5. You could take that y to the negative 3, move it down to the bottom, it'll become y to the positive 3. So in reality, that first parenthesis is going to be a fraction with a 6 up on top, and the x to the 5th is on the bottom and it's positive. the y to the negative 3 becomes y to the positive 3 on the bottom because he moved it, and it's still negative. So let me rewrite this. What we have is a fraction that's negative with a 6 up on top, x to the 5th, y to the 3rd, times 9x squared, 9x squared. If you want to put it over a 1, you can, just so you could see that you do have x's up on top and x's on the bottom, which could be canceled. So when you cancel out both of these x's, all 2 x's cancel out with 2 of these 5, leaving you 3 left over. So what would be left as your final answer here? Your final answer is the number 6 times 9, which is 54. No x's, no letters. On the bottom, you do have the x to the 3rd, y to the 3rd times 1, which is just x to the 3rd, y to the 3rd. So I did forget that the negative sign, this is a negative times a positive, that will be a negative. So yes, the answer is negative 54, x to the 3rd, y to the 3rd. And if you look at the multiple choice, in this case, there is no answer, so it would be none of these.